All right. Hello, everybody. How are you doing today? It's Wednesday. It's week 6. Hope we're all doing well. It's the 3rd of November. How did it get to be the 3rd of November already? Sometimes time seems to be flying by. What questions could I try to address for you today? Anybody there? Am I getting feedback from YouTube that I'm not seeing? So once again, what questions do you all have for me today? I don't have any particular agenda in mind here. No comments at all, huh? I'm not sure if nobody's commenting or if YouTube just isn't showing me your comments. You all don't have any questions for me. It might be a rather short office hour today. No questions, no comments, not even a hello. Hello, MS. How are you doing today? Any questions for me today? Anyone? Glad to hear you're doing well. Nobody seems to have any questions today, so I might just mute myself until somebody asks a question. All right. Hope the pandas stuff is going all right, or indeed whatever it is you're working on so far. So, like I said, if nobody has any questions here, this may be a uneventful office hour. I have no plan of my own. Hello, Aladimajay. I hope I'm saying your name correctly. Hello, Francis. Hello, Deepa. Any questions from anyone here today? Hello, Amal. I have a question. It's oriented in mathematics. Could you please briefly explain the notion of p-values and z-scores? I can try to do so. Yes. How do I strip external links on websites? What can one do when the kernel dies when working on the notebooks? Canorio, that one I'll answer first. What can one do when the kernel dies while working on the notebooks? You don't have a whole lot of memory here on this Jupyter pod to work with. You will likely need to close other notebooks. And I don't mean just close the tab on your browser. I mean you have to stop the notebook running. So, closing this tab right here, I have this mini project open, but closing this notebook, it doesn't mean that the notebook stops running. It's still running in the background. Click on the running tab right here and shut down the notebook. Right, and as I said, you don't have a whole lot of memory, so you can pretty much have, one notebook open more or less at a time with a kernel running. You might have a notebook open where you have stopped the kernel. But yeah, when the kernel dies, it's largely because here in these pods, it's because you're out of memory. So as I said, don't have a lot of notebooks open running with running kernels. If you're working on a mini project, only run the code needed for a particular question that you're working on. Like if you're working on question 3, don't run the code for question 1 and 2. Just run the code necessary for question 3. Mathematics and statistics. So yeah, we could talk a little bit about this. So the idea, generally the idea of z-scores and p-values and so on is, right, we're trying, we want to test some sort of hypothesis. Ash's playlist of previous sessions is where it's always been. If I go to my home page and go to video links and I scroll to the bottom of the page, you'll find the office hours playlist. Right here, that's this link. Where it's always been here. It's this playlist. You click on this playlist and you'll get a YouTube playlist with all the office hours on it. So, sorry, right. So a little bit about hypothesis testing. Hypothesis testing. And I'm gonna, try and stick with the overview without getting into too many of the details. Right, like, we may be looking at a population and, I collect a bunch of data and I want to, I have some hypothesis that I put forward that I want to check. Maybe my hypothesis I think in the usual notation, right, I was going to say the mean height of the population is, I'm choosing an arbitrary number here, 1.65 meters. I might have an alternative hypothesis that the mean height is, is very different from 1.65 meters. Right, and the data that I'm using to test this hypothesis is the data that I've gathered. So I collect my data and I want to, compute these so-called test statistics, right? And largely the whole idea of hypothesis testing is relying on something that we might refer to as the central limit theorem. Central limit theorem, or the, this idea of this law Wow. Law of large numbers. Right. Generally, the idea here is, well, if I collect enough data about this, enough samples from this population, and I were to draw these, draw like a histogram, say, of heights of people, then generally my histogram, is going to look something like this so-called normal distribution. All right, so if I draw, say, something like a histogram of heights, then, right, this is going to look something like this so-called normal distribution. It'll be kind of centered around the mean height of the population, the true mean height of the population. And we'll have some kind of spread or variance around this mean, right? So this will say, I don't know the true mean, but if I were to draw this histogram, because, well, heights are all positive numbers, right? It'll look something like this, not exactly. It will stop at some positive number. It'll stop on, both ends. But this is the idea of this law of large numbers, that if I have a large enough population and I were to, say, draw this histogram, I would get something that looks something like this form. Now, and the idea of this p-values and z-scores and so on, is I want to I want to use the data that I have gathered to test this hypothesis, right? Is this hypothesis true or not? And kind of the main idea, right, is that if my hypothesis right here holds, well, the mean of my sample that I choose, is likely to, be close to this real mean. Or, if this is the real mean, then the mean of my population is likely to be close to this true mean. If my hypothesis is incorrect, then the mean of my sample is not going to be close to this true mean. It would lie somewhere out here on the small tails of this distribution, right? If I think the true mean is this number, this 1.65, but the real mean is, 2 meters, right? Then, then my sample mean is going to lie far away from the mean of this normal distribution. Right, and this is the idea of a z-score, is, we're basically saying, well, assume that this hypothesis right here is true. I'm looking to see if there's evidence to reject this assumption. I can't really use my data. It's kind of a one-sided affair, right? I can't necessarily use my data to confirm my hypothesis. I'm trying to use my data to see if I could reject this assumption. Is there enough evidence that will allow me to reject this assumption? right? And if I'm have enough data, again, while I'm looking at this law of large numbers, you know, and this kind of distribution, again, will look like this normal distribution. If the real average height of the population is very different from this assumption, then, you know, this means that, like, the real mean might lie out here somewhere, or it might, you know, lie over here somewhere. And the idea is that, well, if this is the true mean right here, well, I'm unlikely to end up with a sample whose mean of that sample would lie out here or lie over here in these small tails of this probability distribution. And this is what you're doing, you know, when you're computing a z-score, right? You're trying to see, well, look at this sample data and check and see, you know, if it actually lies out here in the tails of this distribution, right? Is it unlikely that I would have found this sample mean by random chance alone? Right? I somehow picked all of these very, very tall people, which would suggest that the true mean, you know, is actually much larger than what I supposed. Or, you know, I pick all these very short people, and, you know, right, and my sample is suggesting that my assumption is incorrect. This is the idea of z-scores. And basically the p-value is saying, well, what is the chance that under this assumption right here that we made, that I would have found all of these people, you know, that lie on like one extreme or the other. You know, if this p-value is very small, well, it says, all right, my assumption right here must have been incorrect. And therefore I could reject this null hypothesis, this assumption, this so-called null hypothesis, in favor of this alternative. That's the idea behind z-scores and p-values and so forth. So, you know, this is what you suggested. You wanted the notion of p-values and z-scores, right? Is that I'm trying to use my sample to say, well, under this assumption here, well, it would be unlikely that my sample would happen. Oh, but my sample, you know, right, the mean of my sample is maybe very large. All right, this is unlikely to occur if my null hypothesis, if my assumption was true. All right, this is unlikely to occur, therefore my null hypothesis must have been wrong, and I could reject my null hypothesis. And so, yeah, that's the idea here of these z-scores and p-values. You know, and there's more mathematics going on behind the scenes, but that's the big picture. Macau, I hope I'm saying your name correctly. How do you strip external links on websites? I'm not entirely certain that I know what you mean. Like, you have gathered a HTML text for a web page and you want to find the links on the web page. Yeah, we could get to more on the DW Mini projects today and tomorrow and so on. So, Macau, I'm not entirely certain that I understand your question exactly. How do I strip external links so I could find external links? I'm not sure what you mean by strip external links. I mean, are you looking for some sort of browser extension which would do this sort of thing? I'm not sure what you mean. We'll get to exercises 3 and 4 eventually. We've done exercise 1. Exercise 2 is rather a straightforward affair using pandas. I don't know why my browser seems a bit slow, but right, we did the summary statistics yesterday, I think. It was largely a result of getting most of the summary statistics from the described method. Right, we wanted a total mean standard deviation quartile statistics. Most of these, the mean standard deviation quartile statistics, we could get from the describe method of the data frame, right? I'm ordering these columns how I want. According to what we were given here. Oops, sorry, according to what we were given here. I use this order items, quantity, NIC, and actual cost. So I ordered my columns in this fashion. Again, the describe method gives me the mean and standard deviation and the quartiles we want. This information right here is a data frame. The names in bold are the indices of this data frame, right? So I could use the loc method of the data frame to select these rows, which is what I'm doing here. Right, the loc method, I will select the mean and standard deviation and the quartiles. Right, and this gives me 5 of the 6 numbers that I want for each of these items, quantity, NIC, and actual cost. I need the total, not the count. The count is something different. The count is the number of rows where each of these columns is non-empty, right? So there's 973,193 rows where items is non-empty. This is not the total of items. This is not the total of quantity. This is not the total of NIC. How do I get the totals? Well, I compute a sum. I select these columns and I compute a sum, and this will give me the total. This sum right here comes through as a pandas series. I want to convert it to a data frame. We'll do that, converting this to a data frame. It's a data frame with a single column. I'm going to rename that column, so its column is called total. I'm going to transpose this so that this column becomes a row, and I have this data frame here which has the totals that I want. I'm going to concatenate these 2 data frames together, and I just inserted the original code right here, right? I didn't need to do these intermediate steps if I knew how to do all this. Well, I'm not expecting that you would know how to do all of this, you know, off the top of your head. I probably couldn't do it off the top of my head if I haven't, you know, used pandas in a week or 2. So the concat method of pandas takes a list of data frames, and in this case, it'll concatenate them, right? One on top, one below. If I had a third one, it would go below, etc. So I get this data frame here now with 6 rows and 4 columns. This is the order in which I want to give this information to the grader. So I want items, and then I want the total and the mean and the standard deviation and the quartiles as a tuple. I basically want a list of tuples, right? So I want a list of tuples of this form. The first element in the tuple is the column name. The next element in this tuple is itself a tuple, and it'll be the 6 quantities in this column for items, and the 6 numbers for quantity, etc. And so I could iterate over the columns of this data frame, take the column name here and take the values in that column and just convert those to a tuple. That's what we did here, submit it to the grader. So, as I said, most of the information we get from the describe method. We have to do a bit more work to get the total. We have to do some more work to get this data in the format that the grader wants. In some sense, right, a lot of this code here is coming from trying to get this data in the format that the grader wants. Now, I might be quite happy with this data frame right here if I were doing this, for myself or someone else. So the rest of this code here was, getting things in the format that the grader wants. We do a list comprehension to generate this list of tuples. Question 2 is very straightforward using Pandas group by method. All right, and a lot of the work in Pandas can usually be done with using the group by method and some kind of aggregation statistics, or often using the apply method of Pandas. I want to apply a function to a column, or I want to apply a function to each row, or I want to group my data and apply a function to each group. And the group by method right here is going to help us do the thing that we want in question 2. Right, use group by to calculate the total number of items dispensed for each BNF name. So our script here is in the form of data frame. One of the columns is BNF name. I could group by BNF name. Select the items column and do a sum. And let's have a quick look here. Scripts.group by BNF name. This creates a so-called data frame group by object. This is itself sometimes a useful object to look at. Let's call this a variable name. I'll say this is my groups. I think we looked at something like this before. Groups has its own methods. I could aggregate. I could what's for something that maybe less confusing, let's refer to this as my grouped data. My grouped data has these attributes. One of the attributes of my grouped data is an attribute called groups. This is itself a Python dictionary. I think I remember having this conversation the other day, right? This is a Python dictionary. The keys in this dictionary are the unique values in this BNF name column. So, there's a BNF name called 3M Healthcare Cavalon Durable Barrier C. I have no idea what this is for. I don't particularly care at the moment. It's not important for our purposes, right? The value associated with this key is a list of numbers. These are numeric indices. These are numeric indices here, this data frame, right? This is saying, well, this particular BNF name appears in rows 1489 and 1491 and 3296 and 5348, et cetera, et cetera, et cetera. I could take my grouped data, select the items column, and aggregate by getting a sum. And this gives me a pandas series. Right, the index names are the different BNF names. The values are the totals. Right, because this is grouped data, we're summing within each group. This totals right here is a pandas series. A pandas series has a very useful method called IDXMax. This tells me the index where the maximum value occurs. So I know that this drug right here was the most commonly prescribed drug. I want a list with a tuple of one value. I say totals.idxmax. Gives me the name of the drug. And totals of totals. .idxmax as an index will give me the actual value. Oops, sorry, IDXmax. Right, so totals IDXmax with parentheses will give me the name. And then I want to use this name as an index into the series to get the value associated with that index. And so this is the most common item, and this is the most common item that the grader is looking for. Right, totals. Now, this is basically, the index. using this as an index gives me the value in that series. So in the PW mini project, we had to construct the groups based on the values of the fields. It was a useful exercise, right? I think it's a useful exercise in that mini project to, figure out how to construct the groups. I don't think that PW mini project was, done in vain, right? It was lots of list comprehensions and dictionary comprehensions and so on, right? Which are good things to know about. Probably got time to do question 3. So find the most common item by postcode. This is, similar to what we did in the PW mini project. So we're going to have to merge our two data frames. Right, because again, the scripts information, right? Scripts tells us, item quantities and so on. We want items by postcode. Find the most common item by postcode. The postcode information is in this other data frame. So we're going to have to merge these two data frames using the merge method of the data frame. We have to deal with some issues which we had to deal with before, right? Some practices have multiple postal codes associated with them. Use the alphabetically first postal code. Some postal codes may have multiple BNF names with the same prescription rate for the maximum. In this case, take the alphabetically first BNF name. So, again, I have practices. What is the difference between a data frame and a pandas core series? Good question. Basically, a data frame, so we could view a pandas series as a kind of fancy dressed up NumPy array. Let's go back here. So the totals, this is a pandas series. Underneath a pandas series, we have a NumPy array, which we could access with this values attribute. So this is a NumPy array. Totals is a series, right? You can see the NumPy array is 2, 3, 1, 1, 2, etc. Our last value is 59. A pandas series is kind of a fancy dressed up NumPy array. The NumPy array is the values over here on the right. The sort of dressing up part is the fact that this series has an index. This series has an index. We could get a particular value from this series by using, one of these index names, kind of like a dictionary. This should be in quotation marks. All right, this will give me the value associated with this index. So pandas core series is basically a fancy dressed up NumPy array. What is a data frame? A data frame is a collection of pandas series. It's one way that you could view a data frame is to view a data frame as a dictionary, like a Python dictionary of series. So I'll repeat that, right? A data frame we could view as a Python dictionary of series. What are the keys in that dictionary? The keys in that dictionary are the column names. So the script right here is a data frame. So again, scripts is a data frame. It has, a number of columns. I could select one of these columns by using square brackets and giving the name of the column inside these square brackets as a string, right? And this selects this series. This right here, this is a single column. This is a pandas series. Can you convert a pandas series to a data frame? Yes. A pandas series has a to underscore frame method. This converts a pandas series into a data frame with a single column in it. Right, so the to with an underscore, to underscore frame method converts a pandas series into a data frame that has a single column in it. It uses the index of the series. Right, if I said totals was my pandas series, I say to underscore frame, hey, I get a data frame with one column. Uses the index of the data frame, uses the index of the series as the index of the data frame. Right, so yeah, I mean, good question. It's, what's the relationship? Pandas series is a NumPy array. A data frame is basically a collection of pandas series arranged as columns. Question 3. So back to our most common item by postcode. First, can we deal with this issue? Some practices have multiple postal codes associated with them. So practices is our data frame. How many practices do I have in this data frame? I have 12,020. But if I looked at practices and I look at the postcode, and I look at the number of unique values in my postcode, I only have 8,336 postcodes. So some of these practices, right, some of these postcodes have multiple practices in it. But some practices are also associated with multiple postal codes. Right, if I look at this B11 postcode, so practices, postcode equals this. Right, this gives me a true-false series. I could use this as a filter on my data frame. So as I said, some practices have multiple postal codes. Like there's one doctor's practice that may have 2 offices in different locations, different postcodes. Dr. Fred, whoever Dr. Fred is, we're going to merge by, well, we'll see. We're merging by the practice code here. Right, the practice code here in prescriptions, we're going to merge on with the code. We're going to merge on this, right? So this practice value here corresponds to some collection of rows, or some row here in this code column. But as I said, the problem is that there are some, there's like a practice, there's several practices that have different, several offices in different locations, different postcodes. Code is different from postcode. Code is like a name that the National Health Service uses to identify this doctor's practice. And, postcode is, well, based on the location in the country. There's kind of no such thing as a primary key in a data frame. I mean, a primary key is what we want to use, right? You can see this practice right here is repeated multiple times right here. This one doctor's practice has prescribed multiple drugs to different people. So yeah, we need to, so a code may appear several times in this table here with different locations. So some practices have multiple postal codes. Because there's multiple locations, we want to use the alphabetically first postal code for that code here. So let me get rid of some of this. I want something like, I want to identify, I'm going to call this, say, unique practices. I'm going to take my practices and I'm going to I basically want to do a group by. I want to group by code. So let's say, let's look at this here. Group by code. My groups, what do they look like? Like here is a practice that is associated with more than one postcode. Here's a practice which is associated with a single postcode. Practices.look. Right, this code appears twice. So for some reason it's listed, this one for some reason is just listed twice in this data frame. So this isn't necessarily, this is the same location, it's just somehow repeated in this data frame. So that's less interesting. Here's a postal code, or here's a, sorry, practice code, which appears 3 times. Two of these seem to refer to the same location, but there's another one which is at a different location. I don't know. Seems like a bad set of data in that, like, row index 70 and index 1094 are exactly the same. But there is a second location which is in a different address because it has a different postcode. We want the alphabetically first postcode. I'd want this one instead of this one. So what we can do is we can do the following. I can take my practices. I'm going to sort by postal code. I could sort by postal code. I want to then group by the code practice. And I'm going to keep, right, group by, I want to aggregate. There's a method in pandas which will group by, I want to group by and aggregate. There's a method called first. Right, so we take a group and we're just going to keep the first element in that group. Because we've sorted our data first by postcode, this will give us the alphabetically first postcode by taking the first element right here. Right, so now these codes right here should appear exactly once because we group by code. So we take all the rows that correspond to one code. Within that group, we keep the first one. Because we've sorted by postcode, we keep the alphabetically first postcode. I'm going to reset an index right here. And these are my unique practices, this data frame that I'm going to use. Right, we started with what, 12,000 rows or so? We started with 12,000 rows in practices. We've reduced it down to 10,843. This is the information. So let's make a new cell. We want to join unique practices to scripts. I'll take my scripts and do a merge. I'll take my unique practices. I have a left data frame and a right data frame. And I can specify a column name for each. My left data frame, it was using, the column is called practice. my right data frame, the column is called code. The reset index just gives me a numeric index, right? Without the reset index, my indices were the postal codes themselves. It's not really necessary to do so, but right, without this, so back to without this, so copy and paste. Without this, the postal codes were the index of my data frame. I don't really need to do this in this case, but the reset index will turn the code back into a normal column in my data frame and will give me a numeric index back. We're out of time for today, so we could pick up here and check this merge. I don't need all this information from the unique practices. I might just remove the name and the address and so on. All I need is, basically the code and the postcode. I may just, choose to remove all this information. I could remove it by only selecting the columns I want. But we'll do that tomorrow as we're out of time for today. So we'll pick up here tomorrow. We should be able to finish question 3, probably finish question 4. So thanks for your questions, and I will see you all tomorrow.